Okay, it's quarter till. Get started with these shorter sessions. Going to have to keep moving quickly. So, going to be talking today about Lambdas and ways that you can use them to simplify your code. Quick agenda so you can decide if you want to leave right away. We'll start off with a very quick review of Lambdas. I'm assuming that everyone here, I'm hoping everyone here has seen Lambdas, worked with them a little bit in Java 8. But we'll do a really quick review first, and then we'll show some neat tricks you can do with them. Take a little bit of time out to talk about how to deal with checked exceptions, and then talk about some ways that you can take design patterns and turn them into library methods. And then finally, show a few ways that you can maybe increase the static type checking of your code, add some type safety using Lambdas. Now, I want to stress that the idea here is not that you walk away with the specific techniques I'm showing, although you're certainly welcome to do that. What I really want you to do is to get inspired and think about other ways that as you are doing your daily jobs or your nightly hacking, you run into things and think, hey, Lambdas can make this better. So a quick word about me. I work at Myriad Genetics, where we do testing of genes to determine a person's predisposition to getting cancer. Been working in Java for about 17 years. Occasionally I'll tweet, occasionally I'll commit code, and occasionally I'll speak here at Java 1. Okay, last thing before we get rolling, I want to make it clear that not necessarily everything I'm showing you is the most performant way to do something. If you're writing a real-time, life-saving application, this might not be the right strategy to use, although it may be. However, in most situations, for example, if you're in an application that also has to talk to a database or do any other sort of I/O wait, the extra penalty that might be incurred by using Lambdas in these ways is going to be minuscule. But, if you're concerned, do some benchmarks, check it out. Okay, so first of all, what are Lambdas? They obviously were introduced in Java 8. They're more than just anonymous inner classes with some syntactic sugar, although if it helps you to think about them that way, go ahead, because it'll give you a reasonably accurate model of how things end up working out. The key is that they're represented, a Lambda expression is represented by an interface that has exactly one non-default method. You can add default methods to the interface all day long, but it has to have exactly one method to be introduced. Otherwise, a single Lambda is not going to do the trick. Wouldn't know which interface method you're talking about. So in full generality, they look like this. They say, hey, I've got a function from string to integer. I take in a string s, and then what do? I've got this block of code to get the length. But we can, of course, get rid of the string repetition there, and we can, for that matter, get rid of the curly braces in the return, and we're already feeling a little better. And then we realize that s has no purpose being there, so we can just say this. So if this is new to you, I apologize. The rest of the talk might be a little bit difficult to follow. Okay. Most likely, when you first saw Lambdas introduced, you saw them introduced in the form of streams. And you probably saw some example like this. You saw, let's say I've got a bunch of employees and I want to find the salaries of just the engineers, and I want to do it average by city. And so you write something like this. First, I can filter out my engineers, so I'm just looking, or my employees, so I'm just looking at engineers, and then I can group by the employee's city, and then finally I can average their salaries up. And this is really nice. I mean, we're looking at 5 lines of code here that in earlier versions of Java would have taken easily 2 to 3 times as many lines of code. Now, on the bright side, though you would have had to write more code, it would have also been harder to read, and so your job security would have been increased. But at least now, if we're comfortable with our job security, we can be a little bit more expressive. It's also easier to see whether or not there's bugs. And of course, the original motivation for adding all of this was to support parallel processing, because there's nothing in here that can't be done in parallel should you choose. All right, so streams are nice. but that's really not what we're going to be talking about today. Instead, I want to talk about some other ways. So first thing, null-safe navigation. How many of you have ever programmed in Groovy? A few. So you might recognize what this is up here. It sort of looks like Java code. I'm invoking a getAddress method, but there's that little question mark in front of the dot. And then with each subsequent method chain call, there's that question mark. And all that means is, please invoke the method that I'm saying to invoke on the object that I just mentioned, unless that object happens to be null, in which case, never mind, just give me null back. And so the idea is if you're in a space where anything might be null and you need to be careful, then you can use this mode of getting data and not worry about getting a null pointer exception. Now, of course, if you haven't or have programmed Groovy, but you also like Java, you think, it's actually not that big of an advantage, because in Java it's pretty easy. I just have to check, is the employee null or not? And if the employee isn't null, I should check the address as well, and then I should probably check the city of the address of the employee. Okay, once I've figured all that out, I can actually safely invoke it. And so, after you write this sort of thing, you get sad. And you're sad because, you're looking at this, there's a lot of repetition. There's, of course, the more methods you chain, it's actually O of n squared code that you have to write, unless you do some other tricks with temporary variables. Either way, it's not happy. So in Java 8, the first thought you might have is, let's refactor the domain entirely to use optional any place there could be a null. And if you can do that, that's great, and that's probably the best route. But if you can't do that, if you are going to have to deal with a domain where there can be nulls, we can still use optional, or at least maybe abuse it. I haven't quite decided whether this constitutes an abuse or not, but it sure is convenient. And basically what we do is we use optionals of nullable method at the start, so that'll either give me a present optional with an employee or an empty optional if employee was null. And then we start indicating which methods to invoke. This is the optionals map method, which will invoke the method if it's a present optional, and obviously not if it's an empty optional. And then when we're done, we'll say or else null. If that's what you want, you might want to say or else throw if it's a big problem. But the idea here is that now we have type-safe navigation. And the reason this works is because we're no longer saying, okay, here's what I want to do right now. I need to call this method, then this method. Instead, we're saying, here are some things I'd like to do, but I'm not going to do them. I'm going to ask the optional class to do them for me. And it can smartly decide whether or not to do them. And that's going to be a recurring theme throughout this. But in any case, this makes us happy. So that's good. Another example, and I apologize for moving quickly here with the new 45-minute length, trying to get through everything if possible. Another thing, sometimes you have a list of objects and you want to sort of take the first one that's not null. The first one's better than the second's better than the third, but null's not better than not null. So there's various libraries that can do this. Commons Lang is one of them. It has an object utils class, which has a first non-null method, and it kind of does exactly what you'd think it would do. It takes in a bunch of references and says the first one that's not null, that's the one I'm going to give you back, and if they're all null, I'll give you null back. So this is fine as long as all the data that you're providing, or at least all the data after the first instance, are cheap to provide. That it's cheap to compute ahead of time, but that's not always the case. For example, if you're running an e-commerce site and you say, all right, well, I want to give some recommendations to the customer to convince them to buy even more things they don't need. And so the first thing I'll do is I'll look at what's in their shopping cart and see if I can get some recommendations based off of that. And if that doesn't work, then let me see if I can get recommendations based off the customer history. And if that doesn't work, well, let me just give up and show them some of our best sellers. So that's all nice and good, but the problem is that each of these activities might be fairly expensive to do. And moreover, if we're trying to sort of minimize the amount of work we do, then if it turns out the cart was able to give us recommendations, then we wasted time computing the other things. Conversely, if it turns out that the cart recommendation process takes a long time to come back and say null, well, then all that time, if I wanted to give my customer a very good experience, I would have been already calculating other possible sources of recommendations. So and again, the problem here is that we did all this work before we called optional. And so when you do that in Java, a bunch of arguments, it's going to calculate the arguments values in a defined sequence. So it makes us sad. But what we can do instead is we can say, all right, I want to have first not null be a method that takes in lambdas. In this case, these would be suppliers. And so now we simply say, here's the work that I want done, and I want to get the first non-null thing. And this starts to make a lot more sense. Because we've got suppliers, we can either say, don't do the work if I don't need to, or we can say, I want to parallelize it, do it all at the same time to maximize responsiveness. And the method to do this is really straightforward. I mean, I'm sure there's a library that has it, but it's hardly worth looking for a library for this amount of code. Basically, you take the stream of the values that are passed in, which are really suppliers, and then the first thing you do is you say, I want to invoke the get method, and then I want to filter out the ones that aren't null, and then finally take the first element, and if nothing's present, then I'll just return null. And of course, because of the way that streams work, if I do this in serial, it's actually not going to do any extra work beyond what it has to. And if I do it in parallel, then everything, if fork join works out the way we want it and so forth, everything can get done quickly. Okay, so, once again, we're happy. Okay. One problem that you can run into sometimes, though, one of the great things I should say about Java is that with the introduction of lambdas, any interface that had just a single method automatically became eligible to be lambdaized, or whatever that word would be. But some methods, of course, have more than, or some interfaces, excuse me, have more than one method that they specify. And so if I've got something like this, there's not really anything I can do. I can't do a lambda expression to create an instance of this interface. But what you can do is create helper methods. And these helper methods can take in one or more lambdas and construct an instance of the interface for you, so that you don't have to go back to the old days of anonymous interclasses. So a way that such a method might look, one sort of full bore example is we say, all right, well, the visitor interface requires, the file visitor interface requires 4 methods. There's the do I want to recurse into the directory, the pre-visit directory, then there's, okay, here's a file, I want to look at it. And then what do I do if I tried to look at the file and it failed, and what do I do if I tried to look at the directory and it failed? And these are all functions, because at each stage you have to return a constant indicating whether you want to keep looking at more stuff or not. So if I create a method like this, once you've written the signature of the method, the implementation kind of writes itself. We know we're going to need to create some new, say, anonymous interclass. And then for the first method, pre-visit directory, what do I do? Well, gosh, I was just given a path and some file attributes, and I have a lambda expression which will accept both of those, and it will return whatever I need to return, so just invoke it. And the other 3 methods you do in exactly the same way, except you don't put them on the slide because they don't fit. So that's nice, but it's a lot of work. Maybe in your typical use case, you want to just recursively go through an entire file tree. You want to look at everything, and you always want to keep going. And in that case, the visit file method's the only interesting one. So instead, we could do something like this, where we just take in a single lambda expression for the thing we care about, and then the others can have default behavior. It turns out there's a simple file visitor class that makes it easy to have default behavior for the methods that you don't want to override. Do something like this. So this is a nice improvement, because you're back in being able to sort of express yourself functionally. There is one problem hidden in it, though. And the problem is that there's a good chance when someone is given a file or a path, and I apologize that this is the generic really almost is always path. when you're given one of those, there's a good chance that you're going to want to do something that might involve I/O, and that means an I/O exception can be thrown. But what we did before was we were using these standard Java interfaces in Java util function by function, and all of the interfaces in the Java util function package, none of them declare that they throw exceptions, and so we're going to run into trouble. And this kind of goes to a problem that was called exception transparency. The way exception transparency was supposed to work is that you could do something like this. I want to do something for each file. Create new file, can throw an I/O exception, but that's okay because I say that I can throw an I/O exception up on the method here. So that's fine. That's great. But unfortunately, if you try to compile it, if you write it in your IDE, you'll get a red squiggly, and if you try to compile it, you're going to get an error because we're saying we'd like to throw an I/O exception, but it's incompatible with the Lambda, the Lambda interface that we're trying to, the functional interface that we're trying to convert it to. And well, gosh, that's a real bummer. And it really is a bummer. If you've worked with Lambdas much, you've probably run into this problem. You're trying to do stream processing, and suddenly you run into this problem. And so, well, the first thing that you could do is you could, I should mention they did try to fix this, but type theory is hard. And it's especially hard with exceptions because they're neither covariant nor contravariant, and they're a union type, really, because you could throw perhaps either an I/O exception or an interrupted exception. And it's fascinating to read through the list, the mailing list, to see how they tried to solve this, and in the end, it just really was not going to happen. So what are we going to do? Well, one thing that we can do is we can just say, well, we'll catch the exception in our Lambda expression. And if we get it, we'll convert it to a runtime exception. Standard trick that you see peppered all throughout Java whenever you have checked exceptions. I don't know about you, but I don't feel so good about this. This took my one-liner and blew it up into a, I don't know, 7, 8-liner. It's got a whole bunch of stuff that I don't care about. Somewhere buried in there is my create new file call, but everything else is just making me miserable. So you start thinking, well, that's unfortunate. And then the next thing you think is, well, hey, maybe they didn't try hard enough on the exception transparency front. What if we use generics? So we say, hey, instead of using consumer, let's try an e-consumer that can throw some exception type E. And while you can't catch a generic exception type, you're certainly allowed to declare that you throw it. So this works out. And then we could even imagine, hey, if Java had done this in some sort of bizarro Java, then the iterable interface, instead of having a for each method take a consumer, it could have taken an e-consumer, and then everything would have just worked out the way that we want it to. And the funny thing is that this actually works. But you'll notice right away the signature for each just got a little bit more confusing because I suddenly have to put in this extra generic parameter information. But, on the whole, I mean, it does work. It doesn't work if you have more than one type of exception that you need to be able to declare that you throw. You can try making your thing generic in 2 parameters, and type inference will just bail out on you completely. And so that's not happy. And generally, in the end, you just decide it's probably not worth it. And so you're sad. And then you think, why am I sad? I'm sad because of checked exceptions. And now you think, gosh, checked exceptions, and how you're angry. And when we're angry, we sometimes do rash things. And one of those rash things can be just to get rid of the problem. And the solution is to just get rid of the problem. So there are multiple libraries that do this. I like the Juke Lambda library, or just the Joule library, you can call it. What they've done is for every functional interface in the Java util function package, they've created a companion interface with the name checked preceding it, and that companion interface has the same method, but it's allowed to throw any throwable. And then they've provided a series of static methods that will take in for example, a checked consumer and it'll invoke the checked consumer, and if any exception gets thrown, it'll rethrow that as a runtime exception, otherwise just carries on. And so what this means is that now you can write code like the following. And all I have to do is say unchecked.consumer and surround my Lambda expression with that, and I'm back to where I can actually use things. Now, it's a little bit problematic because I'm no longer actually throwing or declared to throw an I/O exception. I mean, I could say that I do, but I don't really anymore. And so that's a problem unless you want to catch it and reconvert it. So, if you think that there's a value in checked exceptions, then that's not so great. And it's also a little more verbose. So maybe not happy, but at least, we're no longer sad. We're kind of meh. Okay. Next thing I want to talk about is design patterns. So what's a design pattern? If you go to Wikipedia, it says, gosh, it's a general, repeatable solution to a commonly occurring problem. Wow, it's general, it's a solution. That sounds great. And it's for things that commonly happen. What's not to like? Stuart Holloway, on the other hand, says it's a code smell. They tend to point to deficiencies in the language. And the reason it's a smell is because of the third word in the definition, repeatable. When you do a design pattern, you are repeating some code that someone else has done, and you're repeating it over and over again. A lot of the patterns are of the form here, write this boilerplate code, then do the thing you actually want to do, and then write some more boilerplate code. And if you look at this with Lambdas in mind, you think, I think we've got a solution. So show a couple examples. First pattern, resource management, sometimes called the dispose pattern. So back in the days of Java 6 or earlier, whenever you wanted to deal with, say, an input stream, you had to go through all this work. You had to first get it, and then you had to do a try block, and then remember to close in the finally block, not in the try block, because you're not guaranteed you get to the close statement. Otherwise, you have resource leaks, and then everyone's unhappy. And so, okay, that was bad. And in an attempt to both make this problem less painful and also forestall the introduction of Lambdas into the language, Josh Block said, well, why don't we have the new try with finally, try with resources syntax. And so this gets a lot better in Java 7. When I do this, I don't need to worry about closing the stream at all. But there's a problem, and that is, well, I don't know about you, but I'm getting old and forgetful. And so I just might write something like this, where I simply say, hey, let me just pass OpenStream into process and be done with it, but now I'm not closing it, and I've got a resource leak. And it's a poor API that lets people make mistakes. So let's look, that's not good. And there's actually another problem too, which is that this whole language thing that was introduced only works if you implement auto-closable. So for example, if I want to use it for managing a lock, I'm dealing with some bank account and I need to make sure that I'm exclusively accessing it while I mess with it, and I say, hey, let's use try with resources for this, and I'm told that lock cannot be converted to auto-closable, which means that this language feature that was introduced to help doesn't help me. And so I'm sad. But if you stop and think about this, really, even this was problematic, because not only could I forget to close the lock, in some sense, you shouldn't be able to get a hold of an account and do something with it unless it's safe to access it. And so maybe instead of thinking about locks all the time, let's have someone else manage that for us. And we get something like this. We say, okay, here's an account manager class. And there's a lock inside, and there's an account inside, but note they're private. The public thing that we offer, the API that we offer, is the ability to work with the account. And this API will handle getting the lock, and then doing the work that is specified, and then finally unlocking. You can do exactly the same sort of thing with the IO stream example from earlier. And this has actually been done. I mean, Hibernate's done this in the session API if you want to get the underlying SQL connection. You do something similar to this sort of trick. And the code now that I write actually looks really sweet because I just have to say what I want to do. I want to work with the account, and what do I want to do? I want to debit it. Much more expressive, much less error prone, everything's nice, we're happy. Okay, so, we're so happy we think, gosh, maybe I'd like to take a break because I'm feeling lazy. And laziness is another thing that there's a pattern for. There's it's the double-checked locking pattern that you've probably seen, where you have to, if you want to have a lazy evaluated, if you want to evaluate something lazily, you first get a lock, or first you check and see if it's already been evaluated. If it hasn't, you grab a lock, and then you check again because memory models, and then if you still don't have anything, you go ahead and compute it, and you need to make sure to store it in a volatile variable or it doesn't actually work, so it's a lot of work to do. So we would like to be able to put that into a library. And in fact, this has been done. So another good library out there for dealing with Lambda expressions is the Vavra library. It used to be called Java Slang, but then Oracle said Java Slang, that contains the word Java in it, which is copyrighted. So they turned the word Java upside down and got Vavra. It works when you look at their logo better. And it's got a good lazy implementation. So we can just see how this works real quick. So I can fire up JShell. If you haven't used JShell, you should be using JShell. Even if you're still on Java 8, have Java 9 sitting around so you can use JShell. And then, let's see, I better do some imports. So import everything I need, and then I'll create a lazy string here. And the work to compute this string is I'm going to print out something to say that I'm thinking so we can see if the work's being done. And then finally return some value, and since we're trying to be lazy, it says right back to us we're a bum, but that's okay. And I can actually say lazy, is this lazy method actually evaluated yet? And it'll say, no, it's not. But if I say lazy.get, it says I'm thinking, and then it gives me back the answer, and that's great. And if ask it's been evaluated now, it says, of course, it has been. And if I say get a second time, it doesn't have to compute it again. So, another good example of something that was a pattern before and is now a library method. And when you think about all the code that had been written using the double-check locking pattern before people realized that it didn't work unless it was volatile, and then people had to go and change all that code, if the same thing had happened here, it was one library method that needed to be changed. So, big improvement. Lots of other design patterns admit similar approaches, but the next thing that I want to talk about is ways that we can increase type safety through Lambdas. There are a lot of APIs in Java which rely on, these APIs typically are ones that are using reflection in some way, and they may rely on the use of strings to tell them what to reflect for. This is not strongly typed code, it's stringly typed. I don't remember who first said that, but it's a perfect way of phrasing it. And it's a problem because refactoring tools don't really know that you're talking about a method name if you've got it in quotes. And the compiler doesn't know, so it's not going to be able to catch typos at compile time, which means you're deferring things to runtime, which typically might happen, during a demo to your boss or something like that, or in, actual live production, which, not so good. But Lambda expressions offer a great alternative here. And in fact, the first example of this, let's take a look at what it takes to make a comparator. So if you remember the contract for comparator, it's a little bit complicated because you need to make sure that there's sort of this anti-symmetry and there's this consistency and there's a bunch of things. And so it's easy to write a comparator and get it wrong. So it's good to have some sort of library that lets you do it, that'll do it for you, excuse me. And so the Common Beans Utils package from Apache Commons has an API that allows you to do it. And you have to build a comparator chain, and then you can say, well, first, let's say I'm comparing people. Let me compare on last name. And if I get a tie, let me do a tiebreaker based on the first name. And unfortunately, this was done without great attention to generics, probably was done before generics, so I actually have to cast it to get what I want. So this doesn't look so good, but a lot of that is not the fault of Java. That was just the API. We could have had a better looking API that said, okay, here, I just want a comparator chain on the person class, and I want to use last name and tiebreak on first name. So this is definitely an improvement, but it's still stringly typed. There's still opportunities for problems, and problems make us sad. It turns out this one is actually solved in the JDK itself. The comparator class added a few new methods, the most interesting one is the comparing, or the most interesting pair, I guess, is the first is comparing, a static method that says I want to create a comparator which compares based off of some function which maps my bean or my whatever to something that is already implementing comparable. And then the other great method is the then comparing method that says, and if that doesn't, if that can't distinguish the two things, then let's try this other method. So you can create now a comparator in just a couple of lines of code. And that couple of lines of code is completely type safe. Your IDE is going to know about it. Your refactoring tools are going to know about it. Code analysis tools, assuming that they're up to speed on Lambdas, are all going to be able to handle this perfectly well. And so, again, that's great. Let's take a look at another example. So this one is, I'm going to be talking about JUnit 5 because it just recently came out and it looks kind of awesome, actually. And they have a few ways of doing parameterized tests. One way is to just have an annotation above your test with a series of strings, and each string is supposed to somehow represent the various data that you want to provide into your test. I should mention a parameterized test is basically a test that runs with different values, and you sort of provide the values one by one. So it's a way of writing a lot of tests without writing a lot of code. So that's nice. The annotation approach where you list all the parameters in the annotation is not that flexible. It only works if you've got one parameter. So more generally, they have this thing where you can say you've got some method that returns, say, a stream of arguments, where arguments are basically some sort of tuple. And then you can write your parameterized test that looks like this. You say it's a parameterized test instead of a regular test. And the data is going to come from this method string int values, and then I've got my test that I actually run. I want to verify that if I parse the, or excuse me, if I take the integer and turn it into a string, that I get what I'm expecting to get. So that's good. This is very good, but it is stringly typed, and so there's a few problems. The first is I might misspell string int values, obviously, but there's another deeper problem here, which is that while my test int value of method takes a string and an int, I have no guarantees that that's actually what's returned from the string int values method. It's just a stream of arguments. And those argument instances might not have a string and an int. They might not even have just two elements, might have one or three. So leaves a little bit to be desired. But it turns out there's another thing in JUnit 5 which is really awesome that allows us to fix this. And what it's called is the dynamic test. So dynamic test in JUnit is basically a way of creating tests at runtime instead of completely specifying them at compile time. And the funny thing is that in this particular case, we can defer things to runtime in a way that gives us more compile time type safety, which is an irony I just love. And the way we can do it is, well, for the example we had before, first of all, and I'm going to use the tuple class from, again, Juke Lambda. Again, lots of different libraries provide tuples these days. But it's a nice type-safe class. It's parameterized in the, generically parameterized in the type of the first and second element of your tuple. And so I've got a stream of tuples of string and int. And then what I want to do is I want to take each one of those, and the first map is a map from the stream class. The second map that you see here is a map from the tuple class, which is a little bit weird, and try not to worry about it too much right now. But the upshot is, once I'm down to something that takes a string and an integer, then build my dynamic test. And when I build my dynamic test, I need to first say what it is that the test should be called, so that when it passes or fails, it shows up nicely in the output, and then secondly, the actual test. And this works. And it's great, it's type safe, but it's a little bit messy because there's this weird tuple map thing that's going on that I don't want to have to think about. And I don't know, it doesn't feel as clean as it could be to me. But if we create one small static helper method, we can make things a lot better. So here's a method, parameterized. And this one takes in functions with 2 arguments. And then you could create a similar version for 3 and 4 and 5 and so forth arguments. But the way it works is you say, well, I take in a test that I want to, or a test creator that I want to run, and I take in some data, and I do that funky double map thing that I did before. And the idea is you write this once, get it to compile, and then never worry about it again, and instead write tests using it. So now if I want to write a parameterized test, I say I've got my test method, and it's a test factory, and I'm going to use the parameterized method to let everything work out nicely. And I'm just going to start off by saying, what's the test? It's a dynamic test based off S and I. I'm not even bothering to specify the types here. Compiler inference is doing all of that for me and doing it correctly. And so as before, the first thing I do is give my test a name, and then I say what I actually want to do in the test. And then finally, the last thing I do is I provide some test data. Now, I don't know about you, but this makes me happy. This is the way you want to write tests if you're writing parameterized tests. Because now you're just saying what you want to do, and you don't have any of the stringly typed mess that was going on before. And in fact, I like this stuff so much that I wanted it even before JUnit 5 had really been built. And so I ended up writing a quick library for JUnit 4. It's a test runner called Lambda runner. I don't have the URL, but if you Google it, it's going to be the only thing that shows up under that. And it basically has an API that lets you do pretty much the same thing. It does require the use of a special test runner, which can cause problems. And because of the way it works, certain JUnit rules don't work out so nicely. So it's not perfect, but it's a nice way, and I've actually found it quite useful. And again, not a lot of code to take something that is painful and turn it into something that's really nice and better type safety. Okay. Last thing I want to talk about is a few best practices for API design. The first is, and this goes back to the file visitor example, if you're creating new interfaces, if possible, create them so that they only have one method. It might actually be better to have 4 interfaces, each taking in a single method, than one large interface, if you can get away with that. And barring that, consider providing people factory methods to create instances of your interface so that they can use Lambdas and enjoy them. Next rule, don't create any interfaces at all. Instead, use the ones that are already out there. JavaUtil function has a number of great interfaces in it, and because they're all generically parameterized, they're going to work for probably 80% of your use cases. And then another 10% of your use cases, they would work, except that you have checked exceptions you need to worry about. And so then you can use, say, the Juke Lambda library again to manage those checked exceptions. This is nice, you know, less classes to load in, less things for people to think about. They'll say, oh, a function. Yes, I know what that is. I don't need to go back to the drawing board and try to figure out what this new interface that you gave me is, because I already understand exactly what it is. Another thing, so sometimes you want, you have a method, and let's say I've got an API that has a method in it to do some work, and it takes in a runnable. And then I think, you know, checked exceptions. That's going to make people sad. So let me also accept a checked runnable, one that won't throw any checked exceptions. It's a weird naming convention in my opinion, but whatever. And this seems like a nice thing to do, but the problem is that both these lambdas, from the compiler's point of view, have the same shape. They both take in no arguments and return no arguments. And throws clauses aren't considered, which means that if I want to pass anything into this as a lambda, the compiler is going to say it's ambiguous, and it's going to force me to instead cast my lambda expression as either a runnable or a checked runnable, which just feels ridiculous. So when you overload methods, make sure you don't overload methods in a way that you might force your callers to actually specify which kind of lambda flavor they're passing in. If the lambdas have different shapes, it works out fine. So for example, if one of these was a runnable and one of these was a callable, well, those have different shapes because callable actually returns something, whereas runnable doesn't. Or, you know, different parameters and so forth. But try to avoid that. The last best practice that I can recommend is to fill out the session survey. Always really appreciate feedback. I mean, obviously, if you like this talk, then I'm glad to hear about that. But I also want to hear about it if you didn't like it, what I could have done better. And I even want to hear about it if you're really angry. So with that, we have a few minutes if there are any questions. Yes? The question was, do I ever think Java will move all the checked exceptions to runtime exceptions? Theoretically, they could, because in some sense it wouldn't break any existing code. But from what I've heard, people like Mark Reinhold and Brian Getz and Alex Buckley say in various forums, it's probably going to be a cold day down below before that happens. So, fortunately, increasingly, when people create new exception types, they extend runtime exceptions. So, it's not getting a lot worse. But, yes, question. Okay, so the question is, what if I'm processing a stream of data and there's one piece of data in the stream which is kind of a poison pill, it's going to cause a runtime exception, and now my entire stream processing is upended and thrown out. And how do I deal with that? Well, it's a little bit tricky. I mean, obviously one thing you can do is swallow the exception. But that doesn't feel quite right, so maybe what you want to do then is, if it's a map operation, for example, instead of mapping to the result you're interested in, you could map to something that is either the result or an exception, so you can kind of accumulate all those exceptions at the end. I think Vavra might have an either type that you can use for that sort of thing. So yeah, if that's something you're worried about, that's what I would recommend, is have some way of collecting the exceptions. Go from there. Other questions? All right, well, I apologize this talk was so fast. I was worried about not being able to finish in time and ended up actually finishing a couple minutes early. But that means that you all can get into the wait list line for your next favorite talk. And thank you.